Alright, so limits is going to be what most of y'all, whether you are taking AP Calc here or you're taking calculus in college, limits is going to be the first section, first topic that you'll cover in calculus. So a lot of people confuse the fact that we are in pre-calculus to think that we are doing calculus stuff. We're not. Okay? We did kind of a continuation of like all of your previous Algebra 1, Algebra 2, geometry classes, but we really didn't get into much like calculus stuff. This will really be the first like calculus topic that we covered. Okay? And that's one of the nice things, I guess, if you want to think of it as a nice thing, if you plan on taking calculus, is that all of calculus is brand new. Okay? It's not like review, kind of like what we did in here. Like, it's brand new stuff. Nobody has ever seen it before, unless you've taken a calculus course before. So it's completely different from the stuff that we've seen up until now, which is kind of new or fun to learn new stuff. And then you also know that everybody else is in the same boat as you, that you all haven't seen this stuff before. So that's why I think calculus is a fun class. Alright? So, limits. Today we're going to be doing a lot of evaluating and graphing. So you might want out a calculator. It might be helpful.
This part what's a pre-calculus limits.
Yes, it is. You have limits at the end. I mean, I still would have covered limits. I just would have done it not out of your book if it didn't have it. But that's why we picked it out. But because you cover limits, and so it's nice to have a textbook that does as well. Yeah, we use the same textbook publishers that the calculus class uses, so it's kind of nice that they transition nicely into the next book. Alright, so this says, what is the function approaching as x approaches 2? So we're going to want to look at the graph. But first we need to remind ourselves of what that graph looks like. What type of function is that? That's the type of like graph we'll have, but what type of function is that? The quadratic, and quadratics have parabolas as their graphs. Okay. So remind me, what is the like big or main point that we like to look at first when we're graphing a parabola? Your vertex. Remember, your vertex is kind of what everything is centered around, alright? So there are two ways for us to find our vertex. Do you remember what they are? We just did a bunch of it in our last unit. So we can put it in a specific form that gives us the vertex. What? Completing the square, right? So we could complete the square with this. But if we're not talking about conics and we're just wanting a basic graph, the other way is, do we remember our formula that gives us the x value of our vertex? Do you remember going over that? Okay, that's good. X equals negative b divided by 2a. So in this case, what do we end up with? So I would have a negative 1 on top, which gives me 1. And then 2 times 1 on the bottom, which gives me 2. So I have 1 x. You guys see how I got that? Yes? Okay. So then how would I figure out the y value that's associated with that point? That's the x value. How do I find the y value?
You solve the quadratic equation.
No. That would give me my x-intercepts if I were to solve it. Plug in that x value. So I'm going to plug in 1/2 into my equation, and what do we get? You want to use your calculator, you can. What? Okay, what is that as a decimal? 1.75. So we're at 1/2, comma, 1.75. Now, what are we gonna get if we plug in 0? This would be 0, this would be 0, so then we have 2. And what's the nice thing about our parabolas? It's the same on both sides. What's the other word for that? What? Symmetric. So it's symmetric about our vertex. So I know that if I have a value of 2, 1/2 away, then I also have to have a value of 2, 1/2 in the other direction. If we plugged in, let's say, -1, what would we get? Not quite. Because you would have minus a -1, so that would give you 4. Which means that we also have to have a 4 on the other side. So that would be our graph. Agreed? So far so good? Okay. Now it says, what is the function approaching? What notation do we use to represent function? Function. F of x. So function is the same thing as f of x, which is also the same thing as what? Your y values. So I'm looking for what y value are we approaching as our x values approach 2. So I'm going to go to 2. So I'm getting closer and closer to 2. We're okay with that. So I'm going to look at what y values is my graph approaching at that point then. 4. So we would say that the function approaches We're all okay with that. Now the reason we use this word approaches instead of like it equals is because some of the times it will equal -2. Some of the time it might not. So this is kind of going to be the idea behind what we're talking about when we're talking about a limit. So the limit of f of x as x approaches a. So we're basically trying to find a y value that our function is getting closer and closer to. So the limit of f of x as x approaches a is if f of x becomes arbitrarily close let me make sure I spelled that right. So R what does arbitrary mean? What is the word arbitrary? Like if I said the color of the car is arbitrary. Have you not heard that term before? It means like it doesn't matter. So like if I said my car has to have 4 doors, but the color is arbitrary. It means like the car has to be a 4-door car, but I don't really care about the color. It doesn't really matter. So basically here we're saying that we can get really, really close, but like not really defining it. And the reason is because in order to define that, you'll have to have some math stuff that we haven't quite gotten to. So that's the best word that we can kind of put in there. Is basically as close as we want to. Okay? So we're getting arbitrarily close to a unique number. We're going to label that as L. As X approaches A, then the way that we write that is the limit as X approaches A of f of X equals L. You can also see it right here. So notice that your limit, your f of X, your equals, and your L are all along like the same line. Your X goes towards A is actually underneath your limit. That kind of makes sense? So if we look at our previous example, okay, how would we write this in limit notation? We would say the limit as X goes to what? What were we going towards? So X was approaching 2, so that's what our limit is approaching, is 2. And we took it of f of X, and then what did we say that our function was approaching? 4. So that would be what our limit would be equal to. Are we all okay with that? Now, the reason why, like I said, we have to say approaches, because like this first example is similar to what we looked at. We have a point right here where if I plug in a number, I get out a number, and that number is the same thing as your limit. However, here I still have the limit of f of X equals L, this y value, even though my point isn't necessarily there. There's a hole in my graph here and on my last one. But both of those still have a limit that equals L. So basically we're looking at like, okay, if I'm looking at this graph, what would it assume to go towards? Or what does it look like it's going towards if it continued in the same way? And both of these, even though there's a hole actually at A, it still looks like as we get closer and closer and closer that it's approaching L. Does that make sense? You don't always necessarily have a value at that A value. Okay? So let's look at an example of that. So this says use a table to estimate numerically the limit as X approaches 0 of X divided by the square root of X plus 1 minus 1. Yes? So on our last one, how did we find 4? We just plugged it in, right? Plug 2 in, because that's what it was approaching. What happens here if we just plug 0 in?
It's equals 0 if you guys are in
It does not equal 0. I agree it equals 0 in the numerator, but what's the problem? The denominator also equals 0. So if I have 0 divided by 0, it's undefined. I can't say that because it's like a catch-22, right? Like 0 divided by anything is 0, but anything divided by itself is 1. Well, we can't equal 0 and 1 at the same time, so we just say it's an undefined form. Does that make sense? So for this one, we can't do what we did on the first one, where we like just plugged it in. So we're going to use a table. So what value are we trying to get close to? Or what is our limit approaching? 0. So we want to pick numbers that are close to 0. What's a number that's close to 0? 1. Sure. So I plug in 1 there. What do I get? probably gonna want to use a calculator because you're down to square root of 2. So just round to 3 decimal places.
Like 4, 1.
Huh? X approaches 0. There's an X with a little arrow symbol.
So down to how many decimals?
3,
What number?
0, or sorry, 1.
Yeah.
So what do we get?
2.4.
4. No, remember we said arbitrarily close, so we can get as close as we want. Can we get closer to 0 than 1?
Yes.
What's the number that's closer to 0 than 1?
0.5.
Sure. What do I get when I plug in 0.5?
2.22.
3 decimal places? 2 point what?
225.
2, 2, 5. Okay, can I get closer than that?
Yes.
Yeah, so let's say 0.1. What do we get when we plug in 0.1?
2.02.
What about 0.01?
2.00.
Okay. So notice that on the left side, okay, these values of x are approaching 0. I'm getting closer and closer to 0. So what does it look like my y values are approaching?
2.
2. Okay? We all alright with that? Now, there is kind of a catch. Oh, I forgot it here. Let's add this in. Approaches A. Gotta add in like a asterisk. So approaches A. From either side. Then my limit equals that. So notice that on both of these, my left and right side are both approaching the same thing. So we have to check our other side of our value. Because all of these numbers are on which side of 0, left or right? The right side. So we also have to pick values that are on the left side. So those are going to be our negative numbers, correct? So I would have -1, -0.1, or sorry, 0.5, -0.1, -0.01. So can we find those values? In function.
For 1, or -1, that's -1.
It should be
I did
positive
that
1.
wrong. I did that.
Wait, 1, but it should be positive, because you would have -1 divided by
Yeah.
-1. Alright, what do we get for -0.5? Other people. George, what do we get? 1 point, what's 3 decimal places?
1.70%.
Okay, I agree. What about -0.1? Somebody else do that? Huh? You got the last one?
Yeah.
Okay, what's that?
1.995.
Okay, what about this one? Somebody get this?
1.9.
Alright. So again, we're approaching 0. What are our y values? Approaching 2. So, what would we say that our limit equals?
2.
2, because your limit equals whatever y value you're getting closer and closer and closer to. Now in this case, we have a hole in our graph. We can't actually plug in 0 because it would be undefined. That doesn't matter. My limit only cares about what I get as I get really close, but not actually at that number. Does that kind of make sense? Questions? Yes? What? This one? Okay. There you go. Yeah.
So just to simplify it, essentially what we're doing is since we can't plug in 0,
Correct.
we're plugging in a bunch of other numbers to find out what 0
What it would be going for.
what it would be doing.
So basically it's like, if we just pretended that we could plug it in, like what would that point be at, even though we don't actually have any point. Yes, that is a good way to think about it. Alright, so let's look at another one. But, so I said from either side, right? So that means that if they aren't the same on both sides, the limit does not exist. So don't worry about all this stuff. The biggest thing to worry about is this blue box. So it says the limit as x approaches a of f of x equals L. We're getting back into some geometry type stuff. If and only if, right? Means that both of these have to be true, okay? The limit, so there's a little negative symbol. It's kind of hard to see here. So there's a minus sign here. This means from the left. So this would be the limit as x approaches a from the left. And then over here there's a little plus sign. And this means the limit as x approaches a from the right. Those two things have to equal L as well in order for us to have an overall limit. Which, in the examples that we see here, yeah, that's pretty straightforward. It makes sense, right, that most graphs are going to be going towards the same thing from either side. However, what's the one type of graph that might throw this off? We reviewed them on Friday. Piecewise functions, right? If I'm looking at a piecewise function, my pieces might not necessarily line up. Yeah? So look at an example of that. So here we have g of x. We don't have like the equation of g of x, we're just given the graph, but we can tell that our graph, if we did find the equation, it would have to be a piecewise function. Agreed? Yes, because we have multiple pieces on our graph. Alright. So on part A, it asks us to find the limit as x approaches 2 from the left-hand side first. And it means, when I say from the left, I'm going to my x value of 2, and I want to look at the stuff that's on the left. Are y'all with me? So I'm looking at, if I'm approaching it from the left-hand side, what y value is my graph getting closer and closer to? 3. Do we all see that? So this would equal 3. Alright? But notice that if I did the same thing, but I approach it from the right-hand side, okay? So I'm using the right-hand graph this time, and I'm approaching it. What y value is this getting closer and closer to? 1. Are we all okay with that? Yes? Now, does 1 equal 3? Not your question. Does 1 equal 3?
No.
No, it does not. So that means that my overall limit does not exist. Because my left-handed limit and my right-handed limit have to be the same thing in order for my overall limit to exist. So let's look at part B. What does the limit as x approaches 5 from the left of g of x equal? So I'm approaching 5 from the left hand side. What do we equal? 2. Okay, if I approached it from the right hand side, what does that equal? Approaching 5 from the right hand side, what does it equal? It also equals 2. So what is my overall limit as x approaches 5 of g of x equal? Two. Are we all okay with that? Awfully quiet. Do we have questions about this? Struggling with an environment. Okay, but something to note. What does g of 5 equal? Or in other words, where is this point at 5 actually located? Where is the point at 5 located? Not 1,